to solve the given exponential equation in terms of logarithms or correct to 4 decimal places. So our exponential equation is 10 raised to the power of x minus 10 equals 6. We want to begin by isolating the exponential part, meaning we want to isolate 10 raised to the power of x. So for the first step, we'll add 10 to both sides of the equation. Simplifying, we now have 7 times 10 raised to the power of x equals 16. Next, we'll divide both sides by 7 to isolate 10 raised to the power of x. So simplifying, we now have 10 raised to the power of x equals 16/7. And now to solve for x, we can take the common log of both sides of the equation because we have base 10 here, or we can write this exponential equation as the equivalent log equation using the definition of a logarithm shown here below. For this example, let's use the definition of a logarithm to solve for x. Looking at our notes for a moment, this exponential equation and this log equation are equivalent, where b is the base, a is the exponent, and n is the number. So let's write the equivalent log equation. We know we'll have a logarithm, and because we have an equation, we'll have an equal sign. And now we'll identify the three parts of the equation. We'll notice how the base is 10. Log base 10 is called common log, and so for the next step, we can leave the base off, because if there is no base given, we know it's common log, or log base 10. A logarithm is an exponent, so the logarithm is going to equal x. Again, notice how a is the exponent, and the logarithm is equal to a. And then finally, because the exponential is equal to the number 16/7, we have log base 10 of 16/7 equals x. So notice how by writing the equivalent log equation, we now have an equation that is solved for x, and therefore our exact solution is x equals common log of 16/7. Again, common log is log base 10, and for common log, we don't need to write the base. So this would be the exact solution for x. Let's also get a decimal approximation to 4 decimal places. Here's the common log button, so log 16 divided by 7, close parenthesis, and enter. To 4 decimal places, we have approximately 0.3590. Before we go, let's verify that our solution is correct by making the substitution for x in the equation. So on the left side of the equation, we would have 7, and then times 10 raised to the power of common log 16/7, right arrow, then we have minus 10, and this should equal positive 6. And notice how it does, verifying our solution is correct. I hope you found this helpful.